Okay, I apologize, everyone. We lost our internet connection momentarily, but we're going to get started now. My name is Vanessa Greer from Wilson Tool. I want to welcome you to the latest webcast in our free webinar series, Coatings for Stampers, What to Use and When. In our webinars, our goal is to bring you expert solutions to common sheet metal manufacturing challenges in a convenient online format. Please note that today's event is being recorded and you'll be able to download the recording a day or so after this event. Also note that due to privacy reasons, the attendee list is not displayed. If you experience difficulties during the WebEx session, you can contact WebEx technical support at 1-866-229-3239. Also, as part of a large audience, you will be in a listen-only mode throughout the presentation. However, if you have questions for our presenter, there will be time for Q&A at the end of the presentation. So we encourage you to submit questions anytime throughout the presentation by using the Q&A box to the right of your screen, which some of you have already found. Just type into the text box and send. Please choose all panelists in the send to list or your question may not be addressed. To submit a question when you're in full screen mode, just hover over the green floating toolbar and select the question mark icon. In addition to myself, I would like to introduce Elizabeth Graham, who will be co-hosting with me today. We'll be sorting through your questions as they come in throughout the presentation. Now I'm pleased to introduce today's presenter, Jerry Dwyer, who is Sales Manager for the Impacts Division at Wilson Tool International. Jerry is going to be presenting about stamping coating. Any questions that aren't answered today can be sent to Jerry at jerry.dwyer@wilsontool.com. With that said, I'll now turn the presentation over to Jerry.
Okay, thank you, Vanessa. Hopefully everyone can hear me and we're back online technically. As Vanessa said, as you guys, as we go through this presentation, feel free to put those questions in. I just want to be clear of what we're trying to do on the presentation here. A lot of questions we get asked is basically, which coating should I use or which coating should I standardize on? Unfortunately, it can't be that easy. So the intent of the presentation today is to more look at the different factors that go into your considerations when you're considering even using a coating, and once you decided you do need a coating, which questions do you ask to try to zero in on which coating it is. So with that, trying to get the page to change here. All right, with that, we'll go to our agenda. So with our agenda, what we want to cover today is common applications, and then again, considerations for using a coating. What I mean by that is when to even consider using any coating, not necessarily a specific coating, but the questions to ask yourself when you're determining whether to use a coating. Variables that affect which coating once you've decided you needed it, and then again, go into explaining the different processes, PVD, CVD, and TD. We'll spend most of our time today talking about PVD, or physical vapor deposition. It is the most common coating, but we'll also touch on CVD and TD, which is chemical vapor deposition and thermal diffusion. We'll jump into some differences between each coating. Again, I'm not here to, my intent is not to talk you into any specific coating, but to look at the different features and benefits of the coatings and try to apply them to what you're trying to solve in your application. We'll cover some frequently asked questions that we hear when talking about coatings in the field, and then eventually turn it over and address the questions you'll have as they come in. So let's get started. Coatings. The basic definition of a coating is a nano layer of differing alloys dispensed on the surface of a cutting tool to enhance hardness and lubricity, and resulting in better wear characteristics. That's about as simple and generic as it can come as far as addressing coatings. The three processes that we see most commonly are a PVD, again, very, very common, the most common, and that stands for physical vapor deposition. CVD, otherwise known as hot process, also known as chemical vapor deposition, not near as common and does have material limitations, but can and almost always is a very good coating and can outproduce or outperform PVD. And then the third one is thermal diffusion, or TD coatings. This is a completely different process that requires several heat treats and polishes between heat treats. TD is a very good coating, very somewhat popular in the form blocks industry if you've got some real high deep forms, tight radiuses, very demanding applications like that. TD may be an application for you. One moment here, we have a little more technical difficulty. All right, so throughout this, we'll have a couple of questions that we will ask you guys, poll questions. And the idea behind these is to try to get you guys, try to figure out where you guys are at with coding. So our first poll question is, what is your current opinion of coatings? A, waste of money. B, they have some value, but you're not real sure. They're limited. You don't know if you get your money's worth. Or C, you're completely sold. You wouldn't build a die without them. So if you could take a minute just to answer the questions, A, B, or C, and it'll take just a minute for the results to come in, but it'll give me an idea where the audience is right now in your coatings. So right now we're still kind of holding off to see the answers. I would assume many of you have used coatings in the past in some form or another, either on cutting tools or possibly punches. Okay, we have the results in. The vast majority of you are sitting at answer B, which tells me you have used some coatings, but you're kind of unsure whether you're getting your money's worth. We do have quite a few people that have answered that they wouldn't build a die without them, so that doesn't surprise me either. The answer here is somewhere between B and C. Coatings are certainly not a solve-all to solve all your woes with your dies out there, but it is certainly something becoming more popular, and it is in fact the fastest growing element in die building. All right, so some of the question, when should I use a coating? Now again, I'm not talking about any specific coating. I'm talking about whether you use a coating at all. These are some bullet points that you should be looking at when you're considering a coating or consider looking at coatings for. High wear applications, HSLA or high strength low alloy steels, stainless steels, any tight clearances or high pressure forms. A high pressure form is anything with a tight radius or possibly forming some of these tough applications such as HSLA. The second one is a big one. Lube availability or quality is not ideal. This is a very common problem in the industry now. A lot of places do not want to use lubrication like we've used in the past because of the expense of cleaning it off because of paint or plating, or possibly environmental reasons. If you are using lube, chances are a lot of you are using a lighter lube than you used to use. I'm sure most of you can remember some of the real thick, sticky lubrications we used to use. Now a lot of you may have switched over to some water soluble or possibly even vanishing oils. Complex draws or forms. You guys, all you got to do is crawl underneath your car or look at some of your appliances out there. You can see we're drawing and forming metal in ways that we haven't done in the past. Another application, whenever stripping is a concern, if you have a punch or you have a cutting profile that has a lot of inches to it, stripping becomes a problem. And note, 2/3 of punch wear comes from stripping. So the better you can strip a tool, the longer it's going to last. Longer tool life. As we know, dies can be very expensive, and high volumes are typically when we look at dies. So if you're looking to maximize your efficiencies, consider putting a coating on. Nothing worse than pulling out a very expensive die in order to sharpen just a small punch. Also, when working with coated materials, painted thin plastic films that are designed to protect the surface of some of the materials we work with, galvanized, galvannealed, even straight up aluminum. A lot of people think aluminum is soft, ductile, piece of cake. Aluminum can be one of the worst places, worst pieces to stamp because of galling and abrasive wear. Shaving applications, when we're trying to cut a hole with a shaved surface all the way to the bottom. Usually that's some sort of a functional hole. Shaving comes with a different set of demands, and what coatings bring to that application is more of a thermal barrier. A lot of the same reasons we use coatings on cutting tools. And also coining and extruding. When I'm talking coining and extruding, I'm talking about taking a punch and extruding down, possibly to tap at a later date, or to maybe run a shaft through or something like that. There's extreme heat, extreme pressures when doing extruding or coining. So when should I not use coatings? There is a place where coating will not help you. Obviously, when you're having catastrophic failure. If your substrate of your punch is cracking, breaking, chipping, or even the second one, deformation. What I mean by deformation is bending or possibly mushrooming. You have a substrate problem. You need to address your material of your punch and either go with a tougher or possibly harder punch, or take a look at your lengths, your diameters, but you got to get past the breaking, cracking, chipping, or deformation. Coating will not solve any of those problems. When you're developing the part, this is something that might sound somewhat odd, but when you got a complex form, we tend to want to make the form block, hit the part, and then measure the part. If we make the form block and then find a tear or wrinkling in your corners, and first thing we do is we run go get the grinder and we grind the coating off, then you just basically have thrown away your money and putting the coating on in the first part. So make sure your developing is done, make sure your part form is correct, and then send your part out for coatings. When volumes do not warrant the extra costs. If you know this is going to be a low run die, save your money, don't put the money into the coatings. You won't get your payback. And also with that goes temporary tooling. Them kind of go hand in hand, the low volumes temporary tooling. Chances are with temporary tooling, you're going to be using a lesser grade tool steels such as 01, 4140, S7. Those materials don't lend themselves well to coatings. All right, so here's some of the questions we talked about at the beginning. And these are the considerations you should take in when you're considering a coating. Number one, tool function. Is it cutting or forming? That's going to start to steer you which coating to lead at. It's also going to tell you to which characteristics to look at when you're looking at coatings. The die design and setup and clearances. Again, small clearances and small radii mean higher pressures. What I'm talking about is forming here. If you got a real tight form into a corner, you're going to have some high pressures. High pressures mean high heat, high friction. You want to move towards the better coatings. Material type being formed. HSLA materials mean higher pressures or forces. High strength, low alloys. Stainless steel, same thing. So you may have a die that you have been running mild steel in, and for whatever reason you decide you want to switch to a stainless steel. Plan on getting yourself into some coatings, because the stainless steel is not going to form as easily. It's not going to roll as easy as the mild steel did, and possibly a coating may help you get through. Also take a look at your die lubrication. How effective is it? I've seen everything out there. I've seen guys standing there with a paintbrush painting it on. I've seen them spray it on. I've seen pretty elaborate lubrication systems. Make sure your lubricant is in the right place at the right time. Traditional PVD and CVD both require external lubrication for best performance. That's one of the wives' tales out there. A lot of people think, hey, if I coat the punch, I don't need to use a lubrication. That may help you by coating the punch, and it may help you go to a lighter lubrication. But if you look in all of the requirements, both PVD and CVD do still require lubrication for their best performance. And also, anytime, whether you're talking coatings or tool steels or whatever, know your baseline. You're going to get a much better payback if you know where you're starting from. So basically, how did it work without coatings? If you have no idea where you started, you'd have no idea whether the money you invested in your coatings is giving you the payback. All right, so issues to consider when selecting the type. So now we've decided we need to use a coating. Now we're starting to zero in on which coatings. Those of you that we visited, we probably handed you a brochure with 10 different coatings in, and you have no idea which one to use. Again, I'm not here to talk you into a specific coating, but these are the questions you should look at as you start zeroing in on which coating. Number one is the tool failure mode, and this is the most important. what problem are you trying to solve? Coatings are good for adhesive wear, galling, abrasive wear, corrosion, erosion, and even a thermal barrier. Again, you see in the note there in the asterisk, coatings do not solve mechanical or thermal fatigue. If you have a high, say, red hot stamping, things like that, coatings will not give you enough thermal barrier to get yourself through red hot stamping. Tool material type, and what I'm talking about is what you're planning on coating. So make sure you know what you're going to coat. Obviously, you're buying punches from us. We're going to be very confident in knowing what the material is. But if you're making a form block or a drawing or something like that, and you're going to send it in, and you're not real sure what the material is, do what you can to find out. And once you do find out what the material is, make sure you stamp it on there if at all possible so it's permanently marked. A2, F7, cast irons, O1s are not compatible with coatings. Consider the material that you're working with, the material that you're going to be stamping, such as aluminum. If you're using aluminum, try to stay away from any aluminum-based coatings. Just like we all know and we learned in Tool and Die 101, like materials do not work well together. Same thing happens with the coating. And also dimensional tolerances. That will help you determine whether you can use a CVD coating or that chemical vapor deposition coating. That chemical vapor deposition is, again, hot process. It's done above tempering temperature, and you can expect some dimensional changes. The rule of thumb is plus or minus 1/1000th minimum. All right, this brings up our second poll question. And if you could reach into your computer and answer the question, A, B, or C, but what is the most valued benefit when using coatings? Is it A, wear resistance, B, lubricity, or C, a thermal barrier? So once again, them are three that we've kind of touched on in the WebEx up to this point, but it'll take just a few minutes to get the results in. But it'd be interesting to know which one you guys consider is the most beneficial when working with coatings. And again, takes just a couple minutes. Has anyone ever had anything outside of these three where the coatings has come in and solved the problem? I would be interested to know that if you want to type that in in the question area. Okay, the results are in. The A, wear resistance, is by far the winner. There is some people out there that have recognized lubricity. The answer to this question is actually all of the above, with the most common reason people go to coatings, surprisingly enough, is B. The most common reason they go to a coating is they're looking for that added lubricity. What you guys answered as far as wear resistance is typically how people think of coatings. But I would question you on that or challenge you on that, saying, would you use a coating on aluminum? We all know aluminum. We all think aluminum is easy to work with. But again, aluminum, some of my most common coatings users are aluminum stampers. So try to think differently about coatings out there. Again, lubricity. 2/3 of punch wear comes from stripping. A coating makes a punch more lubricant. It's going to last longer. All right, great. So let's move on and talk a little bit about the different processes. Mainly right now, PVD and CVD. These are the two processes that we've been talking about most up to this point. PVD being the much more common, and CVD being the hot process or high temperature that's done over tempering temperature. Here they are side by side, so you can kind of see the physical vapor deposition, or PVD, is low temp, below 750 degrees. It's a line of sight coating, which means it does very well on external features. When working in our industry in the die button, PVD is not a good coating for coating the inside of a die button. It just simply can't get enough residual coating down inside the hole. PVD is a great coating for tight tolerance. It means there's not going to be the dimensional movement. You're staying below tempering temperature and everything is stable. There's no post-coat heat treat. Because we're below tempering temperature, there's no reason to go back into draw or to tempering. PVD will work on most metals. Another reason why it's more common. It works on the A2s, the D2s, M2s, M4s. And sharp corners are okay, once again related to the temperatures. So CVD, or chemical vapor deposition, is almost opposite in all of those features. So it's high temperature, you're above tempering temperature. It is gaseous, which means it will go down inside the hole. It will do the inside of a die button. With CVD coatings, you need to have an open tolerance because of that thermal expansion that's going to happen when you grow. Obviously, you got to coat a part once it's finished, so you aren't going to have the luxury to go back to grinding it back into size. You will need to heat treat or temper or draw back the steel after the coating. Again, you're going to put all the stresses in when you put the coatings in. There is material restrictions. Typically, you got to have a D2 or better. So D2, M2, M4, any of the powders. And you have a minimum of 3 thousandths radius. Basically, the temperatures the CVD is put on is going to melt your sharp corners off. So that's kind of a brief, quick snapshot of how the two line up. A couple of the coatings you guys may have heard of, PVD, CVD. Them are just kind of some of the trade names that are out there. CVD, one you may have heard of is TIC. I will note tin. Tin is able to be put on both PVD and CVD process. So be aware of that. They look identical. So why use CVD over PVD? If you have all this trouble with thermal expansion and all of the thing growing, again, as I said in the beginning, CVD can be and almost always will outperform PVD. It is and can be a better coating. However, you have to have the tolerances that allow. It also gives the ability to coat the internal features. However, lead times are much longer, and as I said before, you got to have tolerances that will allow it, and it tends to be much more money. So people tend to steer away from CVD. Main reason in our industry, the punch business, you might think, well, hey, my punch tip, I got 10 thousandths clearance. I don't care if it grows 1,000th. That's true, but the whole punch has got to go into the coating chamber. And if you look at the shank of the punch, we grind the shanks of the punch to 2/10. So if it's going to grow 1,000th, we're going to have a really nice coated punch that you're never going to be able to pound into the punch pad. So hopefully that makes sense. Some of the PVD stamping and applications, you can kind of see on here some pictures of things. Got some form blocks, we got some cutting tools, draw ring on here, but very, very typical applications for PVD. Now what I'd like to do is break into the different coatings that you guys have heard about from us. I'm not necessarily going to tell you which one's better to use where, but I want to point out the things to look at. Whether you're buying coatings from us or anyone else, there's certain things you want to look at when you're looking at the coatings. One of them being hardness, one of them being thickness, one of them being the coefficient of friction, and the last one being acceptable substrate. So can you even put it on the tool you're using? So the first one here is Optima. This is our most common coating. It's titanium carbonitride. Color is purplish gray if you guys have seen it out there. You'll see the coating temperature is 6 to 800 degrees, so we're well below tempering temperature. Hardness. Hardness in coatings are almost always in the Vickers scale. And in this case, 3,500 to 4,000 is the hardness Vickers. Most of us are more familiar with the Rockwell scale, and I know Rockwell's scale doesn't go this high, but if you could translate the Vickers scale, just for comparison reasons, the 35 to 4,000 Vickers would be about 95 Rockwell. So we start with a 60 Rockwell tool steel, 62 Rockwell, and we put a shell on the outside that runs close to 95 Rockwell. Coating thickness. Notice the thickness of these. A lot of people think coatings are inches. We do allow for that when we know it's going to be coated. So if you have a form block, or maybe you got a block you want to have coated, be aware you're going to add that kind of thickness to the side. So if you have a real tight tolerance, you might have to address your punch down in order to coat. Coefficient of friction of Optima is 0.3. What coefficient of friction is, that's the measurement of lubricity or how slippery it is. The smaller that number, the more slippery it is. It's that simple. So as I go through these, I want you to pay attention to those characteristics because that helps you pick which coating to use. So our next one up is Optimax. That's the very same Optima titanium carbonitride coating. Over the top of that, we run a moly disulfide, which is an extremely slippery surface. And the idea behind Optimax is to increase the lubricity. So if you look at our coefficient of friction, we're at 0.05. If you remember, Optima was 0.3. So we're almost 10 times slipperier with the Optimax than we are with Optima. So if you have a galling problem, things like that, you want to look at the coefficient of friction and get as slippery or as low a number as possible. Some of you might have noticed the hardness. We dropped to 2,000 Vickers. That is a tough thing to measure on the Optimax because, like I said, it's Optima underneath it, which is 35 to 4,000, but the moly disulfide doesn't add anything to that. So you're getting a combination of the two measurements there. Forte, that is one of our newer coatings, and this is a little bit different process. It is still PVD or physical vapor deposition. It is still a cold process. However, it's a dual process where basically we do a carburizing before, a nitriding before. So in layman's terms, we case harden the surface to bring it into the 70 Rockwell range. At that point, we throw a proprietary coating over the top. You'll notice the thickness, very similar to Optima, 1/10.5 to 2.5 tenths. Coefficient of friction is 0.2, so very slippery. Where we're finding Forte working is replacing some of the CVD that's out there. Because we're still cold process, we don't have any of the dimensional changes, and we've been able to put the Forte on where somebody has used or have attempted to use CVD and had very good success. So fairly new coating for us, but preliminary results is very promising on this coating. TiCN, just titanium chromium nitride. Again, I'll look at the thickness here. Tends to be about the same, maybe a little bit thinner than the others. However, notice the hardness. This is one of our hardest coatings out here. TiCN may be a good application in stainless. Any kind of application where you have a wear problem, possibly a blue steels or tempered steels, anything high carbon. So that hardness is going to give you excellent wear resistance. Coefficient of friction of 0.4, so not quite as slippery as some of the other ones we talked about before. ALCRN, aluminum chromium nitride. This is the next generation nano layer. Notice again, thickness is about the same. You can figure about 1/10.5 on normal applications with coatings. Coefficient of friction, 0.6. Again, AL, anytime you see AL in the name of a coating, not a good coating for aluminum. AL stands for aluminum. Aluminum on aluminum does not go well. Acceptable substrates, ferrous, non-ferrous. When I say non-ferrous, again, stay away from aluminum, maybe brasses, coppers, things like that. TiZrn, titanium zirconium nitride. We tend to use this in the ferrous and non-ferrous materials. We tend to lean more on this in the aluminums, brass, coppers, and bronze, so the non-ferrous. Coefficient of friction is 0.55 and tends to be a little bit thicker than some of the other coatings that we've talked about. It can be considered a general purpose coating and can be used that way. This is one of the more underutilized coatings out there, and so far, what we've seen, this is a very good coating, especially in your non-ferrous materials. This is tin or wear beater. A lot of you guys are going to be very familiar with tin, titanium nitride. Again, a PVD coating. This is probably the coating you guys are most familiar with out there. You guys have all seen it. It's that bright gold. It's on drill bits, end mills, on everything out there. It tends to be a little bit thicker than some of the other coatings, and this may have a problem with flaking after sharpening it off, and that tends to go with the thicker coatings. But again, you'll look at the coefficient of friction. Look at your hardness. Your hardness is down compared to some of the other coatings that we've talked about. So probably not one of your better coatings for wear resistance. Here's a newer coating on here that I personally have got to be real careful when using this coating. However, I know you guys may be very familiar with it. And that's aluminum titanium nitride and titanium aluminum nitride, TiAlN or AlTiN. This coating has become very popular on cutting tools, and it works very good on cutting tools. It works very good on end mills, drill bits, things like that. The deal with this coating is you got to get to a certain temperature for it to release all of the features that you need. And in a typical stamping application, you're not going to get that hot. Now, with that being said, if you're extruding or drawing, you may get at the point of contact of the steel to that temperature. We have had some applications where we do a deep extrude, like basically pierce a hole and then extrude it out and run a tap in it later, and it worked magnificently. So I would be cautious using this coating. If you don't get to that temperature, you won't gain any of the benefits of it, and you won't see an increase in tool life at all. So now the following slides, what we did was took all the coatings we just talked about, and I know I ran through those fast, but I want to compare them side by side. So the first one here, we're looking at hardness of all the coatings we just looked at. So you'll see that TiAlN is one of the harder coatings we have out there, followed by TiCRN, followed by Optima or Forte. So again, if you got a wear resistance problems, tend to look for something with a harder surface. The next chart is the coefficient of friction. Again, this is the measurement of slippery. So if you're galling, or if you may get a stripping problem, you're pulling a burr up when you're retracting the punches, or possibly you're forming and you're picking up some tearing or some ripping in your material, you will see the coefficient of friction. Again, the smaller the number, the more slippery. So Optimax clearly is the slickest coating that we sell with that 0.04 coefficient of friction. The least slippery is AlCRM, aluminum chromium nitride. And then you'll kind of see where they all land in there. You'll see Forte in the bottom, kind of right in the middle of the pack. But again, that's that other process where we have a carburizing going on first. And here's your thicknesses. As we were going through that, you've seen all the thicknesses were very similar. Some of your thicker coatings out there, tin, TiZRN. The only time that thickness should be a concern is either if you're extremely tight clearances, as in tenth, or you may want to look at a thicker coating if you're looking for that thermal barrier, such as shaving. TiCRN is an excellent shaving application. I know it only shows 0.2, but the chromium works well in the shaving application. Also, tin is a good application because of its thickness. And here's a good, better, best chart. This will be available for download on our website. If you want to take a look at this, this is by no means the solve-all, but it should help you steer into different directions on your different applications. So am I going to say that there isn't one on here where you could move a TiCRN into the best or a TiCRN down into just the good? Absolutely. Again, rule of thumb, starting point, and help steer you guys towards a coating. All right, let me take just a few minutes to address some of the frequently asked questions. These are what I hear when I'm out in the field. And the most common out there, some of them are myths or wives' tales that have been around since the early days of coating. But basically, this is the most common. When I sharpen a coated punch, will I lose all the benefits of the coating? And the answer is absolutely not. The bottom of the punch does nothing. So some of you, the tool makers that have been around the industry a little bit will say, well, once I sharpen it, it's gone, so there's no sense in doing it. All of your benefits are on the side of the punch. And again, I'll go back to the lubricity and the stripping of the punch. 2/3 of punch wear comes from stripping. So if you put a coating on that allows it to be more slippery or strip easier, it is going to last longer and it's going to have longer tool life. Another one is, why bother with coating? The coating just flakes off after they sharpen it the first time. And this was true 15, 20 years ago. And it was kind of the side effect to coating in the process we used to put it on. With today's processes, the adhesion is much, much better than it used to be. And also coatings aren't near as thick as they used to be. So if you basically visualize sharpening the end of a punch and exposing the very edge of the coating, what would happen is that would catch on the material and basically flake off. You guys have probably all seen it, have been around long enough, coatings flaking. With today's coating equipment and the different alloys and the different ways they put it on, this should not be an issue anymore. If I add coating, can I skip the lube or use a lighter water-soluble lube? Possibly, and I would probably say absolutely. Again, biggest reason coatings are growing is because we're using lighter and lighter oils, and we're trying to bridge that gap from the old sticky, thick oils that we used to use versus the water-soluble or even vanishing oils that we use now. So absolutely, can you skip or use a lighter oil? Can I coat A2, O1, or 4140? Now, this will depend quite a bit on who you talk to for coating. I will tell you right now, O1, 4140, we will not coat. We don't feel that you get your money's worth out of it because we can't get the temperatures up high enough for a good adhesion. So therefore, we will just plain no quote. A2 is possible. However, it's going to limit you to some of the coatings. Probably want to talk to you about some CRN or chromium nitrite, possibly TiCN, but we will apply that at a lower temperature, and it will have less effects than if you were putting it on D2 or better. All right, how much will coatings increase my tool life? That's going to vary depending on your applications. Again, that's why I said earlier, make sure you get a baseline. However, based on the most conservative studies that we've done, you can expect at least 2 to 3 times the life. In a lot of cases, we've seen much, much better than that, in as far as 10 times the life in some applications. So, them are some of the more frequent questions that we field out when we're talking about coatings. And I know I went through some of this stuff really fast. Again, I didn't expect to answer all the questions, but we do have a few questions that have come in I'd like to get to. Feel free to keep sending them in as we go through, or if something comes to mind as we're finishing up. But first question comes in, does Forte do internal openings of die buttons? Absolutely. It will do the internal features of the die buttons. I will warn you though, or I would ask the question if I had the ability, as to why you would want to do the inside of a die button. Typically, your die button is all going to be on top. Here's one of them areas where once you do sharpen a die button, typically all of your benefits of the coating are gone off the top of the die button. But if you are extruding, or maybe there's some forming going on in the die button, you would want to do that. But typically, I don't know why you would want to make sure the internal opening of a die button is coated unless you're having a lot of adhesion or a lot of abrasive wear. And in that case, I'd probably want to steer you towards a substrate or a different tool steel. So, good question. How much lead time do coatings add to a tooling order? Another good question, and that varies. Some of our coatings will add just simply 1 day to our lead time, where other coatings can be up to 10 days. As you can see, some of them have multiple processes and will simply take longer to do. So most of your coatings, your Optimas, your TiZRN, some of them, well, most of them are in the 1 or 2 days. And we are one of the few coating or few punch manufacturers that do have our own coating equipment. So when you hear that our lead times are shorter than that, a lot of it is because we have it inside our walls and we don't have to ship to another facility. So are there any other questions out there or anything that I have not seen? All right, with that, I'm going to give this back to Vanessa, and she will finish us up. Thank you.
All right, so first I want to give a big thank you to our presenter, Jerry Dwyer, and thank you to all of our listeners for joining us today. And again, I want to thank you for your patience as we got started a little bit late. Thanks for hanging on with us. Now, for those of you who maybe had questions that were not answered, I guess, or who maybe didn't send them in yet or come up with something later, or for more information on the ideas presented in this webinar, please contact your Impact Sales Engineer, or you can visit us at wilsontool.com.